Okay, we are live. Hey everyone, mic check paramount is what Siddhant is saying. Yes, that's true. So, can you hear us? Are we audible? Are we sounding fine? Is everything okay? Anyone on the chat who can hear us? Arun, can you hear us?
Yes, I can hear you.
Okay. Mayank is saying looking to learn something new. That's great. Um, Online Shikshak is saying hi Arun and Gaurav. Hello, Mr. Shikshak. Uh, Surya is saying yes. They can hear clearly. Okay, quite a few are saying yes. We are audible. Mayank, hello. Okay, so firstly, before we start off, guys, some ground rules and the agenda of this meet. First, if you have any questions, please put them on the Slido link that I'll just share with you now. Okay, the reason being that because this is being cast on multiple platforms and we don't want to miss out on any of your questions, I'll post this on the chat, the Slido link, and it should come to you. In case you're not getting it in your chat because LinkedIn has some issues and Twitter also has some issues on posting comments, so you can come to YouTube. That's one way to be, to participate. So let me just share this link. And for the first 5 minutes, we'll take questions. It's also in the description in case you're not sure where it is. This is the Slido link. Is this session for experienced professionals only? Arun, what do you think?
No, I don't think that the session is just for professionals. I would highly recommend grads also to hear it. Reason being, everyone goes for problem solving, and cache, if you look at it, it is also a problem. What does it do? People insert something into the cache, checks out some values from the cache, removes something from the cache which is already old. So if you take it as a problem, you can see some problem of this sort on CodeChef and any other platforms also. So I would highly recommend people to watch it.
Okay. So this is for college students also. Okay, great.
Yep.
Alok is saying hi, hello. Vivek is also saying hello. Aniket, hello. How's how are you doing? Is this session for yes? Farm, if I have that pronounced right. Hi. Okay. The agenda, like Arun has already mentioned, is to see the low-level design of a cache and to see how you can maybe you can code a cache. Okay. Is this practical? Does it really happen? There are so many libraries for cache. In my personal experience, yes. Many times you don't even want to read the doc of something as simple as memcached also. You don't want to go through that. You just want to create a in-memory map, which is a cache, and then it suddenly becomes a little more complex and a little more complex until you get to the library, versus till you actually have a hash map. In between you have a cache design. Nowadays that's what it is. So this design will hopefully give you some insights on how you can avoid redesigning the cache again and again, and what's probably going on inside the things like memcached or redis. Okay. Like I said, guys, if you have any questions, please post them on Slido. I'll just start sharing my screen now, and we'll see whatever doubts we have, we'll take them here. Okay, 15 votes already. So what is the best caching strategy? Least recently used is 53%. Least frequently used is 40%. FIFO and LIFO. No, nobody believes in FIFO. Everyone is like FIFO 0%. Okay.
Yeah.
Uh, okay, Sharjit is saying hi, Gaurav. Hi. I had BTech CSE final project presentation today. Are we going to discuss libraries like Cache? Kawai is asking us, are we going to do this? Arun, are we?
So we are going to build our own cache. We are not going to discuss any. I don't think will have time to discuss any particular cache. Maybe a little bit info if you could give, because you have a great course on HLD.
Yeah, yeah. I mean, we actually have a in interview ready. If you look at caching, caching is a fundamental concept of computer science. So yeah, I think we have. Hmm, what was that? It was a broken link. Uh,
Yeah.
that is odd. It's really odd. Okay, let's go to eventual consistency. Um, no, this is we are looking at a cache, right? Caching fundamentals. Yeah, we have this stuff here. If you want to see how memcache runs, maybe having a look at this chapter will help. Replacement policies. Okay. So what's the best caching strategy? Let's see Q&A. Anyone with any question? No, not yet. Okay. Okay, I think we are ready. A LinkedIn user is saying, say hi to me without a name. So unfortunately, I can't say who you are. Are we going to discuss the concurrency and consensus quorum for eventual consistency? Okay, this will be the last question we take before we start. What do you think, Arun? Are we going to discuss the concurrency and consensus quorum for eventual consistency?
Mm, I don't think so.
So low-level design, guys, just to clarify, is think of it as a real interview. Okay, don't think of it as a mini project. You can't do a mini project in 1 hour. So, are you going to discuss concurrency? Yes, you can discuss it. Are you going to discuss a quorum protocol for eventual consistency or some sort of consensus protocol? You can discuss it. Important thing to note in a low level design interviews, you are probably going to build something which kind of works. Okay, the important thing is your thought process, your problem solving, and your discussions. So that is how we can think of it. If you're, I guess, senior software engineer, yeah, this makes sense. uh, that's why this is in fundamentals in interview ready, and you have something like machine coding. So machine coding a cache, yeah, you want to know about concurrency, there is asynchronous processing, reading your own writes, these are engineering guarantees. uh, this is a highly consistent cache that has been designed here. But if you want to see the theory of a eventually consistent cache, you can have a look at write policies. Okay, this is again a cache, and we are going to be designing a local cache today, um, which can rather actually, Arun, are we designing a local cache or a global cache?
So we can go ahead and design a cache with whatever policy a person wants to have. So he might want LRU, he might want LFU, he might want. So he'll just have to tell the policy, and he'll get the
Right.
cache ready.
Perfect, perfect. Okay, so that's perfect. So let's try doing that then, Arun. We have given a lot of promises. Let's see whether we actually fulfill it. uh,
Yeah.
let's okay. So
Okay.
starting now, soft whiteboard. I'll just draw the requirement if that's okay,
Yeah.
and then we can start coding.
Yeah.
Or do you want to draw it on your end, Arun?
So actually, not much of drawing is needed in cache, because I think people are very much familiar with cache. So maybe a discussion would help.
Okay, okay. So I'll just note down the requirements then. I won't need any,
Sure.
you
Sure.
know, this is
Sure.
interesting because usually we have a use case diagram, like we have
Yes.
who is going to end up using this cache, and then we have
Yes.
what are the actions this person is performing. But in this
Yes.
case, what you're stating is this is an engineering requirement.
Yeah.
So it's not design make my trip, it's design a cache. And so
Yeah.
what we have then is something like uh,
So we can take it in this way. You have
uh,
to write or make your own cache. That's it. So what's a cache?
right,
What can we do with a cache? So if you see a cache, in a cache you can store stuff, right?
store, okay,
You
yes,
right? And if something is already stored, you can get the value of it. For example,
okay,
if I've stored name as the key and the value as Arun, So if you pass in name, you should be able to get Arun, right?
Okay.
And then there is one more thing, you should be able to remove values from cache. So
Okay.
suppose values are pretty old. So which is that is eviction policy if we talk about. What do we
Okay.
mean
So,
by eviction policy? So suppose the capacity of cache is five things. So you have already added five things now. Now when you want to add sixth thing, of course my cache cannot do not have the capacity to store it, which means I'll have to remove any value and then I'll be able to add that. So which
okay.
value should I remove? Which value should I remove out of all five?
Okay.
Now that is eviction policy. Now there are, like you have asked the question earlier where people have voted, which policy is the best suited policy? Least
Yeah.
recently used, least frequently used, first in, first out. It depends on the use case, how the person wants. So we'll try and write code of let's write code for LRU and then we can generalize it. We'll see
Okay.
how people will tell just the which eviction policy do they want to have, and then they'll get the cash.
Okay. Okay. So in fact, I wrote delete over here thinking that we need to delete stuff, but actually you're not deleting from the cache, is it? You're only setting
No,
values.
no, removing is also there.
Okay, removing is also that. Should we say
Yeah.
something like, you want to set null for that is as good as deletion? That might simplify the API.
No, we'll remove it.
We'll remove it. Okay.
So
So,
let's say the capacity is five units, and I've
yeah.
already filled with 5 units. Now I want something to be stored, so I'll have to remove it. Then only I'll be able to store it.
No, I mean to say, as a user of this cache, maybe as an engineer, do I get
Mhm.
an API to delete keys, or do I get an API only to get or set keys?
Yeah, I think the user will only get the API to get and set. Why would
Okay.
user want to delete? The
You
cache
never
should.
want to delete. Okay. You can,
Yeah,
if you want to delete, then set the key
yeah,
as null. Okay.
yeah.
So now we are in an interesting position. We are saying that there are only two APIs, get and set, and that
Right.
too you mentioned name instead of that key. Okay.
Yeah.
So get key and set, and you have another
Key
key
and
over here.
value. Key and value.
Oh, key and
Set.
value. Yes. Set it. Set what? Yes.
S-
Set key and
Set
value.
key and value. So for simplicity, we can have key and value both as strings. Of course, key could
Okay.
be something else also, and value could be something else also. Integers could
Okay.
be there. So for simplicity, we'll
Yeah, I
keep it
guess
as
you're using a string. Okay, great. And value is any object.
it could be any object. Let's for now simplicity again. Let's keep it as string, but we can have it
String.
as an object also, integer also, image, link also, whatever.
I mean, you are what you're saying is you take an object and convert it to JSON here.
Yeah.
I mean, that's what you want,
Yeah.
and you take any value you have, and maybe you take a hash of it and convert it to string.
Yes.
So then this is a generic cache. This is
Yeah.
as generic as they come. You are
Yes.
storing data, and the interesting thing here, I guess, is not get and set. It is your eviction policy.
Yeah. Eviction
Okay.
policy and storage policy also. How we are storing it,
Okay. Okay.
right?
So so what
So
data
that it
structure do you
may.
want to keep, and what algorithm do you
Yes.
want to use? Okay. So
Yes. Yes.
so
That
what I'm
would be
seeing here
interesting.
is because it's a okay. So this is interesting. So you now have a totally engineering kind of thing where you have an algorithm, and you have this is your data structure. So if anyone asks you, is DSA really important? Now you can show them this video, yeah,
Yes.
because
Yes.
it is practical, and it does come
Yes.
in the real world. Okay,
And it
interesting.
can come as a normal coding question also, and it can come as a proper low level design question also in low level design rounds.
Okay, that brings us to an interesting question. Arjun Rao is saying, do expectations vary by roles? Individual contributor versus manager versus director?
Yep.
They
I think
do.
it
Okay.
does.
So I mean, an individual contributor, especially in the younger age, and we are not talking about staff engineer over here, I guess, will be expected to look more into the. I mean, a director being asked a cache, low-level design of a cache is never going to happen. Yeah. Neither is a
Even
manager, right?
manager.
Low-level
Yeah.
design. Yeah, yeah.
So
So
maybe
I guess
maybe
Arjun.
he's
Yeah.
sorry.
No, no, go ahead. I'm sorry.
So maybe the perfect roles would be SD1, SD2, senior software engineers, P6, principal engineers. This could
Yeah.
be the perfect roles. I don't think manager is asked about cash, or maybe director would be asked about cash.
No, even I don't think so. Maybe they can be asked what technology are you going to use, in which case you
Yeah.
have like many. But yeah, I guess like you have folks who are at staff or principal. Um, I don't even know the spelling of principal. Like, is it PAL, principal software engineer, or is it on principal they are a software engineer? It's hard to say. I guess it should be principal software engineer should be AL, like in a school. But
You can
yeah.
write it architect actually. Architects
Oh
are
yes,
also.
architect is a pretty so tech lead and architect. But
Yeah.
okay, so I guess till this point you are basically asked more on the coding side of things and how you're going to the low level design. On this side also you have low level design, yes, but you have stuff like an additional thing which is concurrent C and uh, other non-functional requirements like how do you reduce latency, how do you make sure that this cache is not bloated, do you consider it to be a global cache, in which case what if one of the nodes goes down. uh, at staff level I think you are also going to be asked stuff like cost, what are the possible solutions over here,
Mhm.
existing solutions, which one are you going to choose, the trade-offs actually come here also, but the internals of it.
Mm.
Tell me memcache, what does it use. Those kind of things are good to have as a staff engineer. Principal, I have no idea what they ask. I don't think principal software engineers are even like I don't know if it's just an interview. Like they are probably they go through the resume and say that okay, this guy has done something amazing, now let's start taking interviews. So
Yeah.
I don't know whether you can go deeper into tech in 1 hour, but I
Yeah.
guess you can. But we are not the right people to follow for that kind of stuff. Please, if
Yeah.
you're here, please watch this video. If you're here, I guess you're here to revise your concepts or something. Okay. Um, yes. So great. Okay. So the requirements are actually really clear. What data structure and algorithm are you going to use for a cache so that it is easily pluggable for different algorithms, or to change the question, what data structure and code design are you going to have for a cache so that it is easily pluggable to different algorithms.
So I think I'm going to use doubly linked list and a hash map.
Oh wow, okay, a doubly linked list and a hash map. Okay.
Yeah.
Okay.
So a doubly linked list. So because LRU was highly voted, so doubly linked list would help me keep record of which one is like which key has been accessed last, then second last, then third last. So it's going to help me keep the record. And a hash map I'll use just to store key and value, because order of one is the time complexity for searching, for putting, and for removal in a hash map. So that's why.
So I mean you have a head over here
Yeah.
and you have a tail over here
Yes.
pointing to nothing. um, okay, so I mean I guess I'm asking, okay, if you have a doubly linked list, um, FIFO is easy to do.
Actually, yes.
LIFO is also easy
Yes.
to do. Yeah.
But we'll see. Now, this is a good question, problem solving question. How are you going to use doubly linked list to, you know, implement LRU pattern? And
Okay.
I'll
LRU.
implement
So,
it. Yes, I'll implement it.
okay. Okay. I'll just write this down. Least recently
Yeah.
used is the pattern
Used.
you want. Also,
Yeah.
you want fast retrievals
Yes.
and search. Okay.
Yes. A cache is that only.
Right. Right.
Fast
Yeah. So,
retrievals.
what are the things you want to do here? I'll just write these down. Search time. You just have two APIs, right? Get and set. So,
Yes.
search time and um, so actually setting time, set time. And
And
finally, you
get.
have eviction, which also is a thing. Yeah.
Yes, eviction is also a thing which is
So,
important.
can you tell me what we are, what are the order complexities of each of these operations, so that based on that,
Um, so
search.
searching. takes order of one.
Order one. Okay.
Yes.
Okay. Okay.
Setting takes order of one.
Setting takes order one. Okay.
Yes. And
Okay. I guess
eviction
that.
will also take order of one.
Okay. And this is
Yes.
for all algorithms like LIFO, FIFO,
N- No, I
LI.
think we can implement it.
Okay, that's a big claim.
Yeah, we can. But we'll implement it for LRU first. But we can have a discussion about LIFO. How will LIFO be implemented? How will FIFO be implemented later on?
Is it? Do you? Okay. Later on, you want to take this. Do you want to? So because I will ask you that how is this going to happen? I'm not going to,
Sure,
ask you to write the code for it.
sure.
Making it super extensible. But what I'm in theory, how is this going to happen? Like LIFO, the last one in should be the first one out. That is the idea.
Yes.
This is not hard. Like because if at any time we need an eviction, this is order one. Okay, so LIFO makes sense. Order one makes sense. Setting, if you need to set a value,
Yeah.
yeah, you have a hash map which tells you
Hash
where to
map.
set. Okay, order
Yes.
one, and search is again order
Order
one.
of one.
So 1 second. Now, how is the hash map and the doubly linked list going to be managed? We'll look into that later. I'm assuming some magic is happening. FIFO is extremely simple, similar. Order one setting is order one because you're using a hash map. LRU, least recently used.
Recently used. So
Okay.
how we can do this is we can keep a map of link nodes also. So if suppose 1, 2, 3, 4, 5, five
Yeah.
keys, of course 5 values. Let's keep it in this order only. One was called first, then two was called, then third. So least recently used is 5 right now. Okay.
Yeah.
Now
Okay.
suppose you want to know the value of 3. Okay. So
Okay.
now 3 should become least recently used ideally,
Oh, okay. Okay.
right?
Okay. Okay. So
Right.
you just grab
So
this. I mean, what's happening here is you make the head. Uh, Suddenly, if you use three, then you say, "Hey, head point to three."
maybe
Okay.
remove 3 from here because
Yeah.
now 4 would be second, 2 would be third, and first would be fourth, and 3 should be come at the last, like
Okay. So I deleted all of its people who point to it
connection.
and where it
Hmm.
points. So this is going to be order one because I just see
Yes.
the next node and its previous pointer is removed.
Yeah.
The previous node and its next pointer is removed, and finally these two pointers are removed. It is now pointing to itself or to null for all
Yes.
we care. Now you made head. So wherever head was pointing to earlier, you make it point there. That's
So
its
maybe
next.
maybe we can attach it to the tail. Head could be the one who is last used, and we can keep 3 at the tail. So which is the most frequently used, or maybe the vice versa, whatever suits you.
Yeah, yeah. No, so now the good thing about this is three is now going to point to one, and one is going to point to three instead of its next pointing here. Its next is going to
Yes.
point over here to three. Okay, so that's next. Actually, this three is three is next. Yeah, one next. No, one previous is going to
No,
point to.
this is circly doubly linked list. I'm not talking about it. So
No,
what
no,
will happen?
it's actually not a circling link list. It's just that the diagram is looking weird. But otherwise,
Okay.
what's happening is three has been now. It'll become easy to see this. A head is pointing at three. Three's next is one. Three's previous is null.
Yes.
So it is the head of the list. One is now pointing. One's previous is pointing to three. Two continues
Yes.
pointing. Two's previous points to one, and now three's next
Okay.
has to be
Okay.
pointed to by
So
three's
uh,
previous is next. So this is not.
so
There's a lot of arrows being drawn over here, of course, but in code it's going to look extremely simple. And if you know how to deal with linked lists, which you should as an engineer, this should be easy to think through. Okay.
so I see a question. People are saying it's a bit confusing. Maybe if Arun can drop as you're
Okay.
speaking.
Okay. Yeah. Okay. No, I'm gonna just jump to it then. set is also order one. Quite easy because you have a hash map, and search is hash map. Least frequently used. Uh, okay, Arun, I will have a moment of faith, and we'll just jump to the code. I
Yeah,
think yes. So
trust me on this. When we'll code, we'll
yeah.
be in a really good position.
Okay, so I'll to I'll just stop sharing my screen, and then yeah, let's see if the code tells us better than the diagram. Yes.
Okay. Are you able to see a empty IntelliJ
Yes,
video?
I'll just add it to the screen.
Okay.
Okay, I'll be sharing these images later
Hmm.
um, with all of us who are watching. But it's interesting to see whether this works or not. Arun, can
Okay.
we zoom in a little bit? There
Yeah.
must be. This is a presentation mode, I think, so that we can see it. Neha Chaudhary saying it's confusing. Surya Kumar is saying it's confusing now. Praveen Kumar is saying it's a bit complex. Uh, he's saying also, could you repeat that? Kawai is saying it's a bit confusing. So I've done a good job. I've sold the algorithm to you really well. Now I think it's Arun who's going to show you in code how this works. So
So, so where can we go into the
yeah, I think
presentation
in
mode?
view, it will be in view, I think.
Okay.
Yeah, to appearance, yeah. It's the second option, I think. Yeah, we have
Okay.
presentation. Yeah. Awesome. So now it's visible.
Good. I think everyone can see. Okay,
Yeah.
so whatever we talked about, what will a cache have? A cache will have a different type of storage, and a cache will have a eviction policy. That's it, right?
Yes. Yes.
So, so there will be two data members.
Just to oh wow, okay.
Shall-
Oh, you have eviction policy as a type, as a class. Okay.
Yeah, and we'll have to make a eviction policy.
Okay. Okay.
Yes, like we discussed, eviction policy could be LRU, LFU, FIFO, LIFO, right?
Okay. So now your algorithm is like, as long as your algorithm does a certain number of things, you're okay with it. Interesting.
So, and second thing would be storage, right? So just to remove these two red things, let's make
Okay.
a
Wow.
class storage and class eviction policy. Okay,
Okay. Intense. Intense. Really intense. So now
right?
you're saying that the storage is any data structure.
Yeah. So maybe people could ask, do not use a hash map. I want to just use a array. So that will also generate. Will make it generic. Okay.
Okay.
Okay. So of course these both need a constructor. So public cache. So what will we get? We'll of course get eviction policy and the storage.
Okay.
Eviction policy.
Such a nice generic cache. It's really interesting. I think
Okay.
you
We
know.
can see
Yeah.
both the reds going.
Great.
Now, what does a cache do? We can put values in it and we can retrieve values from it, right?
Yes.
So these
Oh,
two
okay.
main
The
functions,
APIs. Okay.
what would we get for putting? We'll get of
Yeah,
course
you're
key and a value.
right. String and a value. Yeah.
Yes. So let's keep it string key and a value. Let's keep value also as string, but of course we
Yes.
can modify it later on.
I mean, JSON. Let's say we have to write value over there.
Okay. Of course we'll do something over here, but let's make the functions first. The two things
Got
which
it.
a cache does. Okay.
You're
The
exposing
next
the
one,
API. Okay.
yeah, yeah. The next thing what it does is
Okay, you want to return a value if someone says get. So
Yes.
string value. Okay.
And so what would be the return type? If I'm giving key, so the value return type would be the
String.
string, of course, where
Yeah.
we will have to return the value, right?
Okay.
This is showing a red mark because I haven't returned anything. Of
Yeah,
course,
which is
when we
fine.
return this, red mark would go. Okay. So if you see, storage will have to store something, right?
Yeah.
And eviction policy will have to evict something. So let's go and write storage first, because only then we'll be able to put it in, right? Hello.
Yeah. I'm just like oh, okay. Wow. Okay. Uh,
Okay. So let's what did we decide? We'll keep so what a storage could have. So of course we will decide that, okay, we'll decide this much capacity for a storage. And of course, how you gonna store it, that doesn't matter, that is an internal fact. So let's make use of a hash map. Okay. So a
okay.
hash map. And okay, this is showing a red mark because we need to
Yeah,
import it.
because we have not imported it. So our
Yeah.
storage is has a map inside it. Okay. So
Yes.
tomorrow if the
So
storage changes, then we'll just have to change the storage class. Okay. I was kind of worried that you're going to, you know, like storage will also be an interface which gives you jump to head, or put element on head, and uh, stuff like that, which is also possible. I think folks,
which is
if
also
you're
possible.
watching this, that is possible. Yes, but I guess to keep things simple, right now you're just showing one implementation of storage. If you really want to
Yes.
make it super extensible, you might find common behaviors from multiple implementations and then give it
Hmm.
this way. Okay.
Okay.
Oh, so you have a
Now,
capacity.
yeah, of course, storage will have a capacity. Cache will always have a capacity, right?
Got it. Got it.
So,
Okay.
so now, what will you do in a storage? You are putting stuff into storage. Cache internally has a storage, right? So a cache is putting stuff into the storage. A cache is retrieving values from the storage and telling the value. And of course, it is removing by making use of the eviction policy, right?
Got it.
So three functions. What will we get for add? We'll get a key and a value. It just happened.
Yeah. I mean,
Right?
isn't your cache here only in storage?
So actually, the cache is having two things. No, cache class is having two things. So I'm separating it out. So why am I
Okay.
doing it? I'm following the single responsibility principle actually.
Okay.
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 And second principle which I'm following is open and close principle. So what does this mean? Open and close principle means that it is open for extension, but closed for a modification, right?
Okay.
So if you see, that's why I made it final. Now you can extend it, you can use storage class, but you cannot modify it. Okay.
Okay.
So that's why I've made three different classes: storage and eviction policy. And that's the main so in while writing code, we try to follow these things: single responsibility principle and open and close principle.
Okay.
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 Interesting.
Yeah.
So
So
solid principles. Okay.
yeah. Yes.
Great.
So first
And okay, now I get it now. Awesome. Add. Okay.
remove. What will we get? We'll get a key and we'll have to remove.
Okay. Okay. Yeah, that is true.
The third one is
Yeah, you have a get also. Oh, so your remove is like a evict.
yeah. So remove will use the eviction policy, or maybe remove will directly remove, but the
Yeah.
cache will have to decide by using the eviction policy.
Which one to remove? Okay. Okay. That's a good one.
Yes.
Okay.
So let's go and implement the eviction policy now. Okay. Of course, we'll write functions over here, or maybe we can straight away go and write. Okay. First, let's write
Okay.
it here.
Praveen Kumar is asking, can you please explain the open and close principle here?
Yeah.
I'll Praveen, I'll take this. So there's a open, if you're writing a class, you're writing some software, basically it is open for extension, meaning that an animal can bite, an animal can move, an animal can run, and tomorrow you might say an animal can fly. Okay, so it's easy to extend. Closed for modification. In fact, let me take a better example because I don't think I'm doing justice to this. Uh, if you let me take a logical approach to this. Let's say you write some software and someone comes and changes its behavior totally. This is not good. You're not thinking of your software as a platform. You're thinking of your software as a full block which has to be changed. Okay, so what you want to do is you want to take some core behaviors, put them in one class, and tomorrow if another behavior has to be added on top of it, it becomes a layer. So it is open for extension but closed for modification. You cannot change the existing software. You add newer layers around the software. If it is being modified, that means the software did not do what it was intending to do. If you say like this software compresses a file and then it needs to be modified, right, just so that you do some compression, that's wrong. So I hope that makes sense. Arun, did it? I mean, I don't know if I
Yeah.
did justice to that. Yeah.
No, you did. So it's one the same thing. Let's take example of this cache only. You want to use cache, but why would you want to modify it? So it is
Yeah.
open for extension. People can use a library. They cannot modify it. They can build a wrapper over it, but they can't
Yeah.
modify that library.
Yeah. I think the best way to think of it is you can add wrappers on top of it. You can add layers on top of it. Like in Linux, you
Yes.
can pipe commands. That would be you're extending the feature, but you're not changing the feature itself. You're not going to change cat, echo, those kind of things. Okay.
Okay.
Interesting. There's quite a few comments coming in. I think we'll take them a little later.
Okay.
Let's go ahead with the
Just
code. Yeah.
I would request everyone to hold on. I'm going to make this crystal clear to everyone. Please keep your questions with you. I'll answer each and every question. Just please hold on for 10 more minutes, okay? We'll be done in 10 more minutes. Or you'll be getting your answers for sure. So
Yes.
let's go ahead and implement it. It is just a map. So for all of those who do competitive programming, I need to add it. Okay. So if my capacity is already full, of course, can I add? No. So I think
No.
let's right. So if storage dot size is equals let's say capacity. So in that case, we can return a simple example. Oh, simple message. System dot out dot println that.
Actually,
Uh,
Arun,
mhm,
if the capacity is hit, isn't
mhm.
that the time something should happen?
Of course, that time something should happen, but for now, let's return this. For now,
Okay.
okay, okay, and if not, let's just add storage dot put key comma value. Okay. Second thing is
Oh,
remove.
okay.
Okay.
So I get what you want to do with that line 37. Okay.
Yeah. So if my storage doesn't contain this key, why would I want to remove? Like we can't remove it. So if storage dot contains key, if it doesn't contains key, then in that case I just simply
Yeah.
have to return. But otherwise, I'll just have to return storage dot remove, and that would be a key, right?
Okay. Yeah, I guess you
Again,
can just do storage dot remove key. Yeah. You don't need to return anything.
that would work. Okay, so I need to get the key from here. So if storage contains that key, of course we can have that check also. But let's say dot get. Okay, this works, right?
Yeah.
So storage is built now. Now let's go ahead and build eviction policy. Okay. So what did we decide? And we'll be using a doubly linked list for managing eviction policy. So just imagine that doubly linked list is already there. Okay, let's keep the class
Arun,
as
isn't
doubly.
doubly linked list going to be part of storage?
So I'm just keeping doubly linked list for my eviction policy. Why would I want to keep doubly linked list as a part of storage? Storage is helping me out in just retrieving, in adding, in removing, right? Eviction
Oh,
policy will help me. So these are two different elements. See, I've differentiated, I've segregated the functionalities. So storage, I've kept everything regarding storage in storage file. I've kept everything regarding eviction in the eviction policy, and both of them I'm using in the cache. So putting, so if I want to put something and I can't put, so I will have to evict something. So that
okay,
function is
wow.
present in eviction policy. That's why I said single responsibility principle is this only. If everything regarding to eviction is in the eviction policy class, everything regarding storage is in the storage.
Okay, yeah, that is pretty smart. I mean, if this works, I should say it, but yes, this is really smart. Okay, doubly linked list, yeah.
Okay, so just imagine that double linked list is already there. Of course, we do not have time to implement it.
Let me
Okay,
see if a collection already offers this, no? Java doubly linked list.
and one of the things could be double linked list node. Okay, let's keep it mapper. Okay, Mm, so now a constructor.
So yeah, in fact, Arun, if you want, linked list is a doubly linked list.
Here in Java.
Yeah, in Java, yeah. Looks like.
Uh, Not much is required actually. So let's go ahead and use it only. People can,
Okay, okay, sure, sure.
and the other one is, of course, we'll have to import it.
So when you say doubly linked list node, do you mean
Yeah.
what do you mean? The index in the doubly linked list or the key?
So a doubly linked list is a complete one node, second node, third node, fourth node, right?
Yeah.
So both the nodes are connected. Both the nodes are connected. Both the nodes are connected. So one node.
Okay, okay. One full
So
node okay, of the doubly linked
yes.
list.
So that's how it will help me. So mapper would help me evicting. So let's say I want to remove three. So okay, imagine like this: one, two, three, four. Okay, there's a
Okay,
connection between one, two, and three. Okay,
okay,
let's
got it.
imagine three nodes only: one, two,
Got
and
it.
three.
Got it.
Okay, one is the head, two is in the middle, three is at the tail. Now imagine three is the last recently used, two
Yeah.
was used before this, and one was used the first. Okay, so what would be the least recently used here? Three is the least recently used. Now suppose you access two, somebody accesses two. So of course two is now the least recently used. So how would
Got
you
it.
modify two? So two should come here now. So what would be the linked list now? One, three, and two. It should look like one, three, and two, right?
Yeah.
So how will we make it look like one, three, and two? So I'll have to remove two from the middle, or
And bring
whichever
it here.
place it is, and bring it at the last. So how so if you will traverse the complete linked list, that would be order of n time complexity, right? But I want to do it in order of one. So if I have this node's address, or if I know this node, which is in my mapper, right?
Yeah.
Because value is two, look at it, key is two,
Got it.
and the value is the node. So
Yeah.
now I get the address to this node. I know the previous node, I know the next node because it is doubly linked list. I'll
Huh.
make the connection with 1 and 3, 2 gets out, and I'll append 2 at the tail.
Got it. Got it. I
So,
think as you write code, things will become like ultra clear. Do you
yes.
want to, uh, you know, Arun, maybe just create a class DLL and DLLN,
Okay.
doubly linked list node and doubly linked list? I think we might actually end up implementing also because it's so easy.
Yeah, we might.
We might actually have a single class also by the end of it because every
Yeah.
system.
Okay.
Okay,
So,
so a
yeah,
hash
this is
map of okay.
now. So, what was this? When a key was accessed, right? So, when a key is accessed, the linked list changes, right? So, there should be a function, right? Key accessed
Okay.
key,
Yeah.
and what will it return?
Nothing, I
It should
guess.
return nothing, right?
Yeah.
Okay. So what do I have to do? I'll have to remove this middle node and I have to put it at the end. So
Okay.
okay. So let's say DLL, of course. Let's suppose it is having a function detach node. Okay, we'll
Okay.
make a function detach node in DLL because that is out
Okay.
of form. What will
Okay.
we do? Mapper dot get, and of course I get the
No,
node by
here,
default.
here I am a little skeptical. What
Tell me.
you, uh,
So I'm just
if you say
breaking the
DLL
connection.
dot detach node, yeah,
So I'm just breaking the connection.
you are breaking the
Since
connection in the sense you are telling this linked list. How are you going to break the connect? Aren't you going to
okay,
break the connection of the node?
yes, of course. And so suppose these three blocks are there. One, two, and three. Okay. One and
Yeah.
two are connected, two and three are connected. So I
Yeah.
know
Yeah.
the address to the previous because two's previous points to this and
Yeah.
two's next point to this.
Huh.
So what do I have to do? Its next should point to two's next,
Got it.
right?
Got it.
And three's previous should point to two's previous now.
Yeah. So do you need the whole list? Don't you need just one node? Mapper dot get that
Mm-hmm.
key will give you the node. Now with that
Yes.
node you can detach it totally.
Oh yeah. Oh yeah. We can do that. Yeah, we
So
can do
maybe
that.
you just want to keep a detached node. A DLL dot
Yeah.
detached node cannot come in. Okay.
Yeah. We can have a just detached node also.
So now you've detached that node.
Yes.
All
And
mapping for that is gone. Okay.
yes. And maybe add note at end. This could be another function in the here, or maybe we can have it another function at the end,
Okay. Okay. Okay.
and we just need to pass again this node. We why do we need to create a new node? This node is already present. I just need to put it at the end,
You attached it
right?
at the end. Okay.
End, right? Because that is the least recently used now, right?
Okay. Okay. Got it. And
And
got it.
just return it. Okay. Second thing,
Yeah.
this was key accessed where we were breaking, and of course we made changes. Second is the
Got it.
eviction policy, the evict key function.
Okay. Okay. Okay.
Let's keep it, or maybe
So the
void.
first one runs on a get, and the second one and it runs on a set also actually. And
Second one
now
runs
what
on
you're
set
writing is,
actually.
huh?
First one runs on get. So when you are getting something, now this key is recently used, so this should be put at the end.
Okay.
The order
Okay.
will
When you're
change.
setting, you're not assuming it to be as good as a get. You're just you haven't used it. Okay. Makes sense.
Okay? So evict
Evict
key.
key. You don't really
No,
pass
no.
anything here, right?
Yeah,
Yeah. Yeah.
yeah,
Exactly.
yeah. I don't need to pass anything, right? Okay. So what do I have to do? So let's say, so of course, which one was the last used? The head is the last used, right?
Right. Right.
Right.
Yeah. So
So I
it's
just
it's
need
quite
to
easy. Yeah.
move head by one, right?
Yeah.
So let's say DLL class has my head. It will have head and it will have tail also, right? It will keep a note of it. So DLL
Correct. Correct.
dot, let's say, move head. Okay, maybe it will have that function. It will be done in order of one time only, right?
Yeah. Yeah. You
Because
just make
head
the
equal
head
to
point
head
to the next one.
connects.
That's it.
Yes, head equals head connects, right?
Right. So
And
this is now
this,
least recently used already. Okay. Amazing.
yes. So this is, we are done with the eviction policy. We are done with the storage. What two functions are left? Putting and
Okay.
getting. So how are we going to use this policy and storage? Let's see here. Okay. So when I need to put it, this dot storage dot add, because storage is having that function add right here. That's why key comma value. Okay. And since I've just put it, okay, since I've just put it, so I want to mark this key as accessed, right? Because this is the least recently used right
Got it.
here. So this dot eviction policy dot key accessed, and it should be key. Make sense,
Okay. Okay. Yeah. You have what you have done is interesting. Yeah.
right? And the
Yeah, it
other
works.
thing
It
is,
works.
it's is getting.
Yeah.
Other
So
thing is
you're just
getting.
saying now eviction policy dot key access key. Okay.
Yes. And how will we get string value equals this dot storage
Okay.
dot get, because storage has a function get right here,
Yeah.
and we'll
Okay.
have
You
to
pass the
pass key. We got the key. Now second thing, what do I have to do? Now since I've just accessed this key, so I want
Yeah.
to
You just
mark it as least
you
recent key.
copy line number 17 basically. Yeah. As good
Yes.
as that. Yeah.
Yeah.
So eviction policy key access
Okay. And I just need to return
return the value. Okay.
value here. And
Interesting.
I guess this is done now. This is my
Yeah.
cache.
This. Wow. Okay. Yeah. It's really, really, really simple. It's
Yeah.
super
And
simple. Okay.
I'll
Yeah. I
answer to
mean,
each and every question, but just want to add a few statements right here. What do I have? So every time, it's not necessary to follow, you know, every time interviewer will not ask you a specific design pattern. Of course, we'll use a factory design pattern here, and I'll explain you how we will go ahead, I'll make a question much more complex now. But for now, these two are one of the most important principle which we have to follow. One is single responsibility principle, which means storage is a single responsibility. Second, eviction policy is a single responsibility. DLL, doubly linked list. If you want to implement your own, everything related to doubly linked list should be present in this class. Nothing should be there related to this node. And node should have everything related to node. And second thing, which we had a conversation before also, open and close principle. Open for extension and closed for modification. Third thing, which is very important, should be classes are immutable here. So if you see right here, I've made it already final. So you can't, mutate that stuff. You can just use it. If you want to make something of your own, you can use it. You can build a wrapper over it and use accordingly. But this class would remain as it is. So these three principles have been used for now.
yeah, no, I'm not very sure about if they're immutable. Then,
Uh,
yeah, actually, yeah, they're immutable. Okay, the data
yeah.
members are immutable. Okay,
Yes.
so the reference is immutable. In eviction policy, can you go to eviction policy?
Yes.
Eviction policy is basically uh, an algorithm. So, okay,
Yes.
that is, let's say, immutable. You can make them final, final. Nothing's going to happen.
Hmm.
Uh,
Yes.
Actually, maybe, yeah, no, the head will point to something else. They are some of the references are mutable here, I think, but that is fine.
So
If you need any kind of movement, then you need some sort of.
we can make it final. Can we? So in that case, we'll have to get the mapper here. But why do we do not want a mapper from the user? Because this is eviction policy. I don't people. This is already private, right?
Yeah.
So people from outside can't access. Only the cache class can access it, and that is
Okay.
already final right here. Sorry.
Oh, okay, okay, okay. So, okay, I get you now. Okay, so whatever happens, there's nothing exposed. There's no
Yes.
public variables
Yes.
exposed. Okay,
Yes.
okay. In that sense,
But
yes. The ones making changes will be people in the class. Okay,
yes.
got it. Okay, great. In fact, now. And we can imagine also that detached node is not rocket science. This is in first year
Yeah.
or second year of computer science. You have
Yes.
a
In college
node.
only.
Yeah, yeah. You just want to get rid of references to the nodes and the references from those nodes to you. That's all.
Yes.
That it detaches. And attach is like, again, first year computer science. You just point to that node. Okay, wonderful.
Yes.
I think this
This
solves
is
the problem.
basic. Yeah, this is
Yeah,
basic linked list which every student learns when they start learning data structures.
great. Okay, this actually. So now all that we need to do, cache we don't need to change.
Hmm.
Storage we don't need to change because your storage is a map.
Yes.
It just gets and
And
sets.
why do people want to know if I'm using a map or map in a storage or an array in a storage? People
Yeah, yeah,
just want to
exactly.
use cache.
Right. So depending on your storage, your time
Hmm.
complexity might change, but
Yes.
exactly like you don't. That is not your problem. You have made it
Yes.
extensible that you can use not just a map, you can use a tree also tomorrow.
Yes. Yes.
Okay, got you. Like Java actually does use a tree, I think, underneath. If you
Mhm.
if you have a map which has too many nodes for one bucket. Okay,
Mhm.
great. What else do we what else do we have?
Maybe we can move to the questions now because I'm done implementing
Yeah,
the
yeah. This is
basic
this
cache.
was super fast. Okay, this was like I think in 20 minutes you finished off the cache implementation. Okay, great. This is a much cleaner and precise solution. Vishesh is saying that this is really good. Um,
Okay.
you probably applied somewhere. I don't want to highlight that. Yeah. Arun, can you explain on whiteboard linked list part is confusing? Okay, we will
Okay.
get to that.
Okay. Okay. Can you send me the? Let me open my whiteboard, or
Yeah,
if you can share the link of a whiteboard, any,
yeah.
so that I
I'll
can.
start. I'll try to share my screen and uh, what I'll do is let me give me another chance.
Okay.
What I'll try to do is I'll try to explain this in an easy way using your code. Right?
Sure.
What you said is first detach node.
Okay.
Okay, so let us assume that three was accessed.
Hmm.
Okay, now what should happen? I think is clear. You said detach node, so I'll try to detach this node. I'll first put three here. I'll first take these nodes one.
Okay. Can we do one thing? Can we do one thing?
Yeah.
Uh, let's do it in a flow. Okay. Whichever flow I tell, just try
Okay.
to mimic that. Okay. Can we
Okay.
erase everything right now? Can we erase everything
Yes.
right now?
Yes, I can get a new
Yes. Just make a
whiteboard.
new sheet. Yeah.
Okay.
Okay. Make one map right
Okay.
now. Just a rectangle. Okay. Would work. Yeah. We can make a partition in the set. Yeah. Key and value. Okay. Okay.
Okay.
Let's make three nodes now. One, two, and three. One, two, and three. And of course,
Yeah.
those will have references. And we can make a linked list also one, two, and three.
Okay. Okay. So there's a linked list of one, two, and three, and
Yes.
it's in this order.
Yes. One, two, and three. And since it is doubly, so of course previous connections are also there.
Okay.
Okay. Head is pointing to one, and tail is pointing to three. Okay. Now,
Okay.
now to everyone. Okay. Three is the one that is least recently used for now. Okay. Now,
Three is the
if
one that
I
is least recently used. You had a access over here.
yes.
So now,
Now what happens? Now everyone, I am asking my cache the value for two. So two is the one that is least recently used now. Okay. So what should be the order in which I'm not? I'm just asking what should be the order in which the linked list should be looking for now. So it should be one, three, and two, right? One, three, and two. It should look like this.
it should look like this: one, three,
Three,
and two.
yes, because
Okay. Okay.
two should
So you're yeah in the tail you're keeping the
yes,
least recently used. So first three
yes,
came in. So you were very happy. Three was this order was right. Then two came. So
hmm,
two has to go ahead of three. So now you
yes.
have one, three, and two. Okay.
Yes,
Okay.
we'll
Till
see
this
how
point,
we'll
everything.
move to. We'll see how we'll move to. But this is
Okay.
how it should look like. The final should be the below one which Gaurav has made.
Okay.
Initial
Yes.
is top one. After we access to the final linked list should be like this. The below
Okay.
one. Okay. Now, since my map knows where which node has two, so accessing map is order of one,
Okay.
right?
Okay. So
So I get
101 is the value.
yes,
102, 103. These are like physical addresses, references. Okay.
yes,
And
yes,
I'll just give 101, 102, 103. Okay.
yes.
Just to show
So
that
I
this is a like order one. You just go to the address.
yes.
Okay. Okay.
So I access my map, and using the map, I straight away get okay, two is right here. So go on two. Let's go on to go now, Gaurav.
Okay. 102 means here. Yeah. Yeah. I came here
Yes.
in one shot. Order one.
Now, if you see in a linked list, now we have to convert it to below. Now, so if you make the connections, Gaurav, below ones, so
Yeah.
one should be one's next pointer should be three. Three's previous
Okay.
pointer should be one. Three's next
Okay.
pointer should be two,
Okay.
and two's previous pointer should be three.
Yeah.
Right?
Yeah. Got it.
So, so if we look at above, 2's previous pointer is 1, right? In the
Yes,
above one.
two's previous pointer is 1. Yes, this one.
Yes. So can we
Yes.
write somewhere so that people are not confused? 2's previous pointer is 1. And
Yeah, I'm just making them blue.
yes, yes, that works. And
And
2's next pointer is 3.
okay,
2's
green.
next pointer is 3. So can we connect 1 and 3 now?
Can we connect 1 and 3 now? Okay, how can we do
Yes.
that?
So 1's next pointer will connect to 3, and 3's previous will connect to 2. Oh, 3's previous will connect to 1,
Okay, so what
right?
two's
So
previous, you said
I
2
know
dot previous.
is
Okay, that
equal
gives
to
you
1,
1.
right?
Okay,
2
then
dot
2 dot
next,
previous dot
नहीं 2
next.
dot next, नहीं 2 dot next,
2
अभी के
dot
लिए 2
next.
dot next is equal
2
to
dot
3.
next to give you 3. Okay, yeah, that is correct.
Yes. So now I got my, मेरे को दो लिंक मिल गए ऐसे. सो बीच में एक लिंक था, मेरे को उसको हटाना था, मेरे को पीछे का लिंक मिल गया, मेरे को आगे का लिंक मिल गया. अब मुझे इनको
Okay,
जोड़ना है. हाउ विल आई जॉइन इट?
yes, yes. So then now you're saying 2 dot previous
Dot
dot
next
next is equal
equal
to
to,
2 dot next.
yes,
Is this correct? Okay.
yes,
And then you're
but
saying
now
2
the
dot
connections are
next.
changed. This is basic
Yes,
C++, guys. This is basic
yes,
coding.
yes. Is equal to, now this also we can say is 2 dot previous.
Yes.
Okay.
So
And because we know that this is a temporary variable and it's going to get affected. Uh, no, this is enough. No.
yes, not, this is enough. This is right.
Yeah,
क्योंकि
this is
मेरे
right.
पास
So,
हो
okay.
गया.
So what happened is now
1
suddenly
and
let's
3 are
go back
connected.
here. Huh.
1 and 3 are connected now. अब मुझे
1
2
and 3
को
are connected.
लास्ट में कनेक्ट करना है.
Got
अब
it.
मेरे को 2
So
को लास्ट में डालना है. सो टेल का रेफरेंस मेरे पास है ही ऑलरेडी, जो कि मेरा 3 को पॉइंट कर रहा था.
correct, correct. So
So
आपको two you want to put it at the end.
yes. So क्या करूंगा? So tail dot next equal to 2 and 2 dot previous equal to tail, and then
Okay,
I'll
so you
make
have
the
a
new
tail
link.
pointer also. Okay.
Yeah. So we can keep a tail pointer order of 1. Space complexity is also order of 1, just a variable.
Tail dot next
Yes.
is equal to
2
2 and
2 dot
2 dot
previous
previous
equal to
equal to
tail,
tail.
and
Yeah.
we can update the tail now. Tail equals to 2.
So this pointer 2 dot tail dot next points to 2. Okay, very good.
Yes.
So I'll draw that. And this is in
Below you have
green.
already drawn it. Below you have already
Yeah,
drawn it.
yeah, but this is the next pointer. I know it is confusing, but in memory, this is exactly what is happening, guys. And logically, you can see what's going on over here. In memory, the next pointer is pointing to 2. And finally, 2 dot previous, which is this thing, is now pointing to null. So actually, I know it might look confusing. You can watch this at home also as long as you want, but I don't
This
want
is
to make
basic
it.
linked list. Basic
Yeah,
linked list.
basic
Removal
list.
from a linked list, inserting in a linked list.
Yeah. In fact, now it's very clear because if I want to go to next, what happens? Head points to 1, green. Once green points to 3, 3's green points to 2, and 2's green has been removed actually. It now points to null. Yeah.
So 2's next should point to null at last.
Yeah. 2's next is pointing to null. 2's previous
Yes.
should point to
3.
3.
2's
Yes.
previous. Yes. So that's why we had tail in 3, na?
Yeah. In
So
fact,
tail
2's
is stored.
previous you can see is pointing to tail. Yeah. So it's
Yes.
clear. And then finally, tail has to point to 2.
Yeah. And tail equal to 2.
Okay.
Yes.
So that takes
So
care of this.
we get the below linked list now.
So it's clear. Green first one, then the next one. This line is 3. So this one was correct. Then it went to 3, correct. 3 pointing to 2, that is correct. Which points to null, that is correct.
Yeah.
If you want to go previous, 2's previous is 3, that is correct. This one. 3's previous is, you can
1.
see this line, 1, that is also correct. And so double check marks everywhere. and this is the list.
Yep.
Okay, this is pretty easy to understand. And in fact, take your time. You can watch this section 10,000 times. No one's going to, tell you that, oh, you're not getting it soon enough. There are no prizes for being first. There are only prizes for understanding. So
I
okay,
can see people writing. They got the same question in Uber
yeah, I
interview.
guess Uber is asking a lot of caching questions. Is it?
Maybe
I
you
don't
are
know.
picking stuff that was asked in Uber only.
Okay. No, I actually did. It's not my. No, I actually we named it Amazon something, right?
Yeah.
Yeah, so it's got nothing to do with that, but it's interesting. Okay. Saurabhjeet is saying when you hit capacity in storage, you are not removing the nodes from DLL at that time. How are you managing your execution policy stay in limits? Yeah,
So
yeah,
he's right. We should have removed. Yeah.
yeah. Just basically in your code, what you're going to do then is you're going to say evict,
Yeah.
right? Okay, yeah, that's okay. That's a single line. Okay.
Yeah.
Thanks, Arun. It was good, clean, precise. Neha
Oh,
Chaudhary. Okay, thank you. Can you implement DLL or DLLN? This is a doubly linked
yeah.
list, and we
Plain
can.
exists.
Yeah, try doing this at home. Actually, it's a good assignment. Just try it. See if it compiles. See if it runs. Write some test cases. It's good. It's not going to happen in an interview, I think,
Yeah.
but
It,
do give it a shot. It will work. The algo is strong. Uh, One of the crisp implementation. Thanks, Arun. Okay, Surya Kumar is
thank you.
happy. Great, Arun. That's Praveen Kumar is also quite happy about this.
Thanks, bro.
Cache is just a fancy map, Arjun Rao. Actually, yes,
Yeah.
most caches are, but there's a lot of hardware optimizations also, and many other things that go into a cache. So it's not just a map. In some cases, it looks at how memory is managed by an operating system and then behaves in that way. Like Arun made an algorithm like that. There's a really complex algorithm sometimes. Okay. Um, Praveen was actually going through the example with us. Um, okay, do a LLD on Jira project management. Interesting. We can
Jira
we
is,
can.
of course, Atlassian's tool.
Jira is Atlassian. Yeah, guys, if you don't
Yeah.
know, Arun is a SD2 at
Two.
Atlassian. He's working as a software engineer at Atlassian. So I don't know if there will be a conflict of interest. But the fact is, really, really, honestly speaking,
Yeah.
you know, whatever we do in this live session is nowhere near the amount of complexity and engineering that is required to make something work in the real world. This is a good concept, an introduction, and good for your if you're in a team discussion or something like that, if you're in a design discussion for your career, understanding these concepts is important at a high level. Obviously, if you spend 3 months on a particular project, you're going to come up with far better ideas with product stats also on how people are using it. So take it with a pinch of salt. This is great as a concept, and it can always be like the serious production level code. Don't expect of it coming in a YouTube video. Okay, if we ever sell it to you that way, that this is how the production level code works, that means we are lying. Okay, so कल Amazon का बार रेजर है, सब लोग मिलके दुआ करो मेरे लिए, शुभम शर्मा. Okay.
Okay.
Okay, great explanation, folks. Okay, guys, this is really good. Thank you so much. What I'll do now is I'll try to see if there are any questions on Slido. Okay, and then we can you implement DLL and DNN? This is something that we talked about. I'll just go through them in sorted order of votes. Surya Kumar, I saw in the last video of inventory, apart from class diagram, use case diagram plus basic class design, is it mandatory to write full code for the same? Arun, what do you think?
No, so by full code, I mean interviewer just expects you to write the signature, no implementation. Just define it. No implementation is required because they have tested how you implement functions in your coding rounds. They know that you can write code. What they want to know is how you break your code. Like we discussed in today's session, single responsibility principle. How you try to use that, right? So no implementation. If he wants to see implementation, he'll ask you, but I don't think he'll ask.
Got it. Got it. So the logic, awesome.
Yeah.
Redis versus Memcache.
HLD question. Gaurav, go ahead.
Yeah, I guess you should definitely have a look at this. This is a really, really good place to go. And I'm not selling the course for selling the course. I genuinely mean this is actually a really good resource, because uh, it kind of depends on your requirement. Okay, most popular, if you ask me, yeah, Redis. If you want a very basic cache, like just a very simple wrapper over what you need to do, like a map only, memcache. Uh, but if you want a local cache, yeah, memcache. If you want a global cache, Redis. Uh, yeah, if you can invest, this is definitely worth it for you. What is the use of doubly linked list? As we are just modifying it, where are we using it? As in
Okay.
reading it.
So we are using it in
So
the eviction policy just to keep track on which was the least recently used. Just to keep
got it.
that
Yeah,
track of ordering. Just to keep the track of ordering, we are using it.
the algorithm. Yeah, perfect. I
Yes.
think, is this cache design applicable for in-memory cache, or we are building it with a point of view of and cache application? I guess it can be used for both, right? It's not really
Yeah.
an in-memory cache and a global cache. The difference is not huge, guys. It's not like a cache is very intelligent. Unless you have a cache which talks to other caches. An
Hmm.
in-memory cache and a local cache are extremely similar. You shard on your keys. If you want caches to talk to each other, possible. You just need a broadcast protocol. Just need to talk to all the caches. Uh, yeah, but that you can build on top of this also. This is like each cache node can have this local intelligence. Okay. Is coding expected in LLD round interview? Yeah, I mean, I think of all the things, I guess this is very easy to answer. Okay. Final question. In eviction, let's say data is last node in double linked list. What would be time complexity?
Eviction data is last node. It's order of one. We have tail, we have head,
Yeah, I
and
I
for
guess the,
middle,
the, the question is, do you have a tail pointer? Yeah, it was
yeah.
asked around 1 hour ago. So it's a
Uh,
it's a good question, but yeah, with the tail thing, it becomes order one again.
yes.
So if you want to remove from the middle of the list, it becomes a problem. Otherwise, it's easy. So okay, interesting. So cashless. Replacement policies, you can use anything over here. Okay, quite good. Okay, okay. Uh, where should I watch this interview later? It'll be there on YouTube. You can watch it. You should you can watch it
Yes.
as long as you like. There are some sections which are a little complex. Do watch it for a longer time. Um, yeah. Uh, Jessima is saying great explanation, folks. Thank you.
Thank you.
Um, Praveen is saying yes. How we organize the code. I guess in that is a separate thing we can take, and especially for a cache over here, we will have some algorithm package. We'll have storage
Mhm.
package, and we'll
Yeah.
have the models.
And of course, and then we can follow this interface delegation principle also over here, where we can have packages for all the different thing, and we can have interfaces made, and then we can go ahead and implement the functions in the interface. So why I didn't do it? Because it's an interview, and in an interview, of course, it will take time. So what you can do is you can just talk about it to the interviewer that we can have intervention. What do we say? Interface delegation
Yeah,
principle. Uh, but of course, it will take time, and interviewers not really looking for that.
got it, got it. So that is interesting to see again. Okay, so this is great, folks. This is perfect. Another low-level design question taken. Um, Let me actually incentivize you to just check this out. Let me sign out. Oh, there's Zoom class also, but that's only for folks who are already there. We are having it on 4th of, when is the next one? It's on Monday, 19th. So Arun, you can come there. I mean,
Sure,
you are an enrolled user, of course. Um,
sure.
Small announcement, guys. You can use Monsoon Special to get a discount on the coupon on the course, 15% off. You can click here to unlock. At present, we are not accepting UPI payments, not because we don't want to, but because we are having some technical issues. So if you have a card or if you have any other payment method, that's good. I just wanted to announce this because a lot of our users are having issues. Around 50% of our Indian users are using UPI. So yeah, but if you have some other way of paying, Monsoon Special is a pretty good coupon code that you can use. Okay, awesome. Thank you everyone for coming. Thanks Arun for making this possible. Let's catch up later. See you then. Bye bye.
Bye everyone.